All right, everybody, welcome to the video here for either lesson 11 if you're in Regents or lesson 12 if you're in Accelerated. I decided to make this homework assignment the same for both classes. I figured some of the stuff we were doing was challenging enough, so I didn't really want to overly challenge the Accelerated guys and girls. And the Regents kids, this is the level that you should be able to do. So I know for homework, I asked you to just do a couple of these questions, but I figured I'd do all of them for you. This way, if you want to practice the other ones, you have the answers and we don't have to worry about that. So for number one, it says state the zeros of the function and then sketch a graph of the function. So the zeros of this function are going to be f of x is equal to a bracket. We always want a solution set. And we want -5, -1, and +2. This negative on the outside is meaningless when it comes to the solutions or the zeros. It just tells us something different happens about the graph. Now, if we plug this graph into our graphing calculator, we're going to notice that you don't see the whole thing. So we're going to have to scale the graph, right? So I'm going to make my scale go up to 30 and down to -30. Now, if on your paper it doesn't have graph paper, if it's just an x and y axis, you could just make your sketch and keep going. Now, I know that my graph is going to touch the x-axis at -5, -1, and 2. Also, I know each one of them has an odd multiplicity, so it's going to pass through at those points. Now, the other thing that I notice, if I hit on my calculator and change the window so that I see the whole graph, there's a minimum value at about -3.5, -21. So somewhere around -3.5, I'm going to be at -21. So I'm going to be somewhere around here. It's just a sketch, so it doesn't really matter too much. So I know I'm going to come down here, and I'm going to go back up. Now the next point that's like a maximum or a top of a hill is going to be somewhere around, 0.6 or 0.7 all the way up to almost 13. So somewhere in between 0 and 1 up to 13 or so is going to be somewhere like that. Again, it's just a sketch. It doesn't have to be perfect. And then it's going to go on forever in the opposite direction. Something that some of you forgot on your quick quizzes and Accelerated, don't forget to give it a name, right? Everything here has a name. Now, the other thing that asks us to do is to find when f of x equals 0. This is just a fancy way of trying for us to find the y-intercept. Where does this graph cross the y-axis? Well, if you look in your table of values, just look for where 0 is equal to x. So in your table of values, you're going to have all these points. You're going to have 0 and 10 in there. So I know x equals 10 for that problem. No. Y equals 10. Sorry, I had that backwards. So my y-intercept there is just y equals 10. Number two, algebraically determine the zeros of the function. So to algebraically do this, we're going to separate it up, plot x squared, x minus 2, plot -1, x minus 2. We can then factor further, x squared minus 1, x minus 2, and we get 0 is equal to x plus 1, x minus 1, x minus 2. So our solutions are going to be -1, 1, and 2. None of them have multiplicities other than 1, so we're good. Then says sketch the graph. Again, go through and sketch your graph if you just have an x and a y-axis. If you're a person that needed the scale here, we just have to kind of take a look at how our scale is going to look. So if we graph this, we have x cubed minus 2x squared minus x plus 2. If you hit zoom 6, it gives you back a regular zoom, which you can use for this. Right? I know it's also going to pass through the y-axis at 2. So it's going to look something like this. It's going to come down and back up. Just a sketch. It doesn't have to be perfect. Also, don't forget to label it f of x. It says to label the maximum and minimum values. Remember, maximum and minimum values are just the points where we have a hill, right? So this would be a max. This would be a min. Eventually, we'll learn how to even find those. For right now, let's just label them. Number 3, f of x is this funky looking function. It says graph it on your calculator, state the zeros. So the zeros are x equals -1 with a multiplicity of 2, 0, and 1 also with a multiplicity of 2. It then says state the solutions, same idea, right? Solutions and zeros are the same, right? So if we want the solutions for when f of x is equal to 0, right, I'm just putting 0 equals, right? We could go from there, right? So solutions and zeros are essentially the same thing. Sometimes you'll see zeros are shown as points like 1, 0, right? 0, 0, you get that answer, right? Also, this point's very important because it's also going to be the y-intercept. X-intercepts are going to be -1, 0, 0, 0, and 1, 0. This question is basically saying zeros, solutions, and x-intercepts are all exactly the same thing, okay? This is how we write solutions. This is how we write points, letter x-intercepts, or zeros. Number 4 says write an equation that's a degree 4 polynomial, that's important, has one x-intercept at 5 and at -3. And we want this in factored form, right? So if it's a degree 4 polynomial, that means the multiplicities have to add up to 4. So if we write this as p of x is equal to, well, if one x-intercept is 5, I'm going to have x minus 5, and I'm going to put it to the second power. Same thing with x plus 3. Why? Well, I know each of them has an intercept at 5 and -3, but it's a degree 4 polynomial. So I can make it so that both exponents are 2, or I can make it so that one exponent is 3 and the other one is 1, or vice versa. I could even have a number in front as a coefficient. All those things are possible answers here. There's an infinite number of answers here for number 4. Number 5 says let f of x equal x minus 1 times x plus 3 to the second, and g of x equals x minus 1 times x plus 3 to the third. It says state the zeros of both functions and their zeros multiplicities. Describe the effect that the root having an even multiplicity has on the graph. So if we have f of x's solutions are going to be x equals -3 with a multiplicity of 2 and 1. I'm going to have x equals -3 with a multiplicity of 3 and 1. Because of the multiplicity of 3, the graphs are going to look very different. So for f of x, if I was to sketch f of x, I know you don't know all of the reasons why the arrows are where they are, right? But I know it's going to pass through certain points and touch others. So it's going to look like this. It's going to touch at the -3 because it's an even multiplicity, and it's going to pass through 1. So that's what that graph would look like. For g of x, I know it's also going to pass through -3 and +1, but it's going to completely go through -3 It's going to completely go through -3. It's going to do something here and then completely go through +1 and end like that. So essentially, by adding another number here in the exponent, I've changed the overall degree of the polynomial. I went from a degree 3 polynomial in f of x to a degree 4 polynomial in g of x, meaning I've changed what the graphs do at the end. That's what we're going to start talking about over the next couple lessons. For right now, just understand what's happening at the x-axis. That means you know what you're doing. Number 6, if you forget how to factor a polynomial, how can you use the graph to help you factor it, right? So each factor comes from an x-intercept. So if f of a equals 0, then x minus a is a factor. We talked about that in class. Number 7 is like a great quiz or test questions because it really tests on all of the actual factoring methods you should know. So for the first parenthesis, that should factor to x plus 6, x minus 6. For the second one, this is where we use that AC method. So it multiplies to make -12, that adds to make negative 11. That's negative 12 and 1. So then I can factor that into 2x minus 12, 2x squared minus 12x, plus x minus 6. Factor out 2x, right? So I'd have 2x, x minus 6, and a 1, x minus 6. So the two factors there are going to be x plus 1, x minus 6. Same thing's going to happen here. I'm going to break this up. So I'm going to have x squared, x plus 6, and negative 4, x plus 6, which is going to give me x squared minus 4, which factors to x plus 2, x minus 2, and an x plus 6. Those are all of our factors. Clean it up a little bit. I have an x. I have x plus 6 once, twice. I have an x minus 6 once, twice. I have a 2x plus 1. I have an x plus 2 and an x minus 2. The zeros for this function are x equals. Smallest number was negative 6 with a multiplicity of 2. Next smallest number was negative 2, negative a half, positive 2, oh no, 0, positive 2, and positive 6, also with a multiplicity of 2. Quick check. The multiplicities add up to 2, 3, 4, 5, 6, 7, 8. If I was to multiply all the first variables together, I would get 1, 3, 5, 6, 7, 8. So I have the right number of multiplicities, so we're good. Factor this expression. Difference of two perfect cubes. 3x minus 5y squared. 9x squared plus 15xy squared plus 25y to the fourth. Where did I get that? What multiplies by itself 3 times to make 27x cubed? That's 3x. What multiplies by itself 3 times to make 125y to the sixth? That's 5y squared. The first term of the trinomial is the first term of the binomial times itself. 3x times 3x is 9x squared. The middle term is the product of 3x and 5y squared, which is 15xy squared. It's positive because it's same opposite, so opposite sign. The last term is the 5y squared times itself, which makes 25y to the fourth. That's old stuff. Number 9, if x plus 3 is a factor of this polynomial, if you are watching this and you were in my Regents Algebra 2 class, you should know how to do this for tomorrow's quick quiz. So if that is negative 3, I'm going to put down my 3, my negative 4, my negative 35, and my 12. The 3 comes down. Negative 9 gets multiplied. We wind up having negative 13, 39, positive 4, negative 12, and then nothing. So if we go through and factor that, so we have x plus 3 as one factor, and 3x squared minus 13x plus 4. I then can factor that expression, so we're going to multiply something to make 12, add something to make negative 13, that's negative 12, negative 1. So I can break that up in the middle, so be 3x squared minus 12x minus x plus 4. Divide out 3x, that leaves us with x minus 4. Divide out negative 1, that leaves us with x minus 4. So my three factors are x plus 3, x minus 4, and 3x minus 1. That's a good question. Last but not least, find the value of c. So to find the value of c here, if f of 4 equals negative 4, this is the x value, this is the y value. So if I plug in negative 4, and I plug in my 4 for all of the x's, I should be able to solve for c. Right, so if I do 4 to the third power plus 4 squared minus 4, we'll combine all those like terms first. I have negative 4 is equal to 76 plus 4c. Now this becomes a simple Algebra 1 problem, hopefully a simple Algebra 1 problem for you. Negative 80 equals 4c, divide by 4, and c is equal to negative 20. If you were in my Regents class, if I was you, just as a kind of general knowledge type question, I would go back in the previous lesson, because if you want to know what's on your quiz tomorrow, you should know how to do number 6. So if you have to, look back and check out the video there for the previous lesson in your book. Hopefully this all helps, and I gave you a big hint there for your quick quiz tomorrow, and you can go through and study and get ready for that. If you're an accelerated, just know that there are no more quick quizzes this week. You're welcome, Giselle, and make sure that you're starting to look at and study for next week's test. You will have a test next week. Good luck with your homework, and I'll see you all tomorrow.